Hello guys, in this video I would like to explain about the hypothesis testing procedure, which is general in this case. So I will talk about general hypothesis testing procedure in case of one factor analysis of variance, which we call one factor ANOVA. I have done 2-3 videos about the general concept of analysis of variance as compared to the t-test, and then I have done two further videos about the models and assumption of analysis of variance, which assumption we required for hypothesis testing, I mean for analysis of variance. Of course, that include hypothesis testing, and which model we need for one way of analysis of variance, and we have calculated mean for each, for each factor, for each level of the factor. You can go there in the playlist and you can watch those videos before this video, because those videos are important for understanding this video. So this I will start from formulation of the hypothesis, and let's go straight to the hypothesis testing procedure of under the one factor analysis of variance. So the initial step is as like the hypothesis testing under t-test and z-test, like those tests, you need to formulate your null hypothesis and alternate hypothesis. So let's see that. Consider m samples. That means we have m population and we are comparing m population on the basis of m samples. So we have m population, we need m samples. Consider m samples, each of size n. So each sample has n observation. That sample size is n for each sample. Suppose that these samples are independent and that sample I comes from population that is normally distributed with mean mu I. So this means that suppose we are talking about the ith population, sample i's come from the population that is normally distributed with the mu I. So and variance sigma square for I is equal to 1 to m. So there are m samples. So each has sample size n, and so that's why mu I mean that each sample is coming from a population with the mean mu I. So this means that ith sample is coming from a population with mean mu I. So this means that if this is sample 1, this means that is with mu 1, if sample 2 with mu 2, and if it's sample m, that is with mu m. The population has mu m with variance. Their variance is common for all, and we assume that the variances are same. This is given in the assumption in the previous video. We will be interested in testing the null hypothesis. So we have m population. In the real life, we will have 3 population or 4, 5 or something like this. So we will test this general procedure. So we are talking about m population. So the hypothesis, the null hypothesis, that mu1 is equal to mu2 and that is equal to mu m. This means that the mean values of all population are equal, and alternatives against this hypothesis, that is totally opposite, that we call rival hypothesis. These are equal, so this means not all means are equal. You can write here as well, all means are equal in the null hypothesis, and in the alternate hypothesis, not all means are equal. Okay, that is, we will be testing the null hypothesis that all the population means are equal against the alternative hypothesis that at least 2 population means differ. So this does not mean that all population mean are different. Maybe there are some are different, some are equal. So yes, we can do this. And if you are interested further which means are different and equal, then you need to do some further testing. Maybe we will do that in some other videos, not in this lecture. So the first step is formulating the null and alternate hypothesis. The second step is decide about significance level. So that's mean if it is given in the problem, in the statement of the problem, like 0.05, 0.01 and 0.1, something like this is given, you can use that directly. If it is not given in the statement of the problem, then you can choose one of them, 0.05, 0.01 and 0.10. These are the values of the significance level that we call normally alpha. the most frequent values which we are using normally in hypothesis testing. You can use any one of them, just assume. And the third step, test statistic. And the test statistic in case of one sample, one factor analysis of variance is n s bar square and divided by summation I from 1 to m si square divided by m. I need a small correction. This is not distributed f chi-square. This distributed f. Okay, that this is okay. Okay, because this has chi-square distribution, this has chi-square distribution, and then this ratio up to chi-square distribution is f distribution with m minus 1 and to m and to n minus 1 degree of freedom. So this is m minus 1 and to m and n minus 1 degree of freedom. These two are the degree of freedom. This degree of freedom come from numerator and this degree of freedom come from denominator. I will have a separate video on this because this is very important to understand. So I will have a separate video on this, the degree of freedom. Now, what are these quantities? S bar square is equal to I from 1 to m x I dot minus x bar double bar whole square divided by m. So this means that we have mean values like this, x I dot. This means that we have, suppose we have 3 rows, then we have 3 means x1 dot, x2 dot, and x3 dot. And then we calculate the mean of these means like this. So x bar double bar is equal to I from 1 to m x I dot divided by m. So this is the mean of the means. When you calculating row means, then you calculate the mean of those means, that is called x double bar. So the mean s bar square, this means the means of the variance of the sample means. You know, we are interested in one factor ANOVA. I mean that we are just calculating the impact of one factor, different levels of one factor. So we are just calculating this. We are assuming this is row factor only, and we will be talking about two factor. In that case, we will be talking about row factor and column factor in two factor analysis of variance. So these are row means. I mean, if this is x1 bar, that means first first level of the factor means, x2 bar second mean of the second level data for the factor, and x3 mean third level mean for this factor, and this is the total mean. I mean the mean of the means. Okay, so in this statistic, and si square is the variance of each sample. So you can see that si square is sample variance of the ith sample. So is 1 square mean is sample variance of first sample, is 2 square mean sample variance of second sample, and the third is 3 square mean sample variance of third sample. So if there are 3 samples, then you need to sum all these 3 variances and divide by 3. So you can calculate this thing. We will have an example in the next video, so you will see that how you can calculate these quantities. You will then understand very clearly. Okay, so this is about test statistic, how we can, because this is important. You should know these things, how to calculate these quantities. Now look at this. Calculate the value of the test statistic from sample data given to you in the problem statement. So you have the data, then you need to calculate these variance, which again is given here in the previous video. There's in the previous slide, this was also given. N is the sample size, or sample size that is equal for each sample, and m are the number of samples. Or this is distributed as f distributed with m minus 1 and to m and n minus 1 degree of freedom. This degree of freedom coming from numerator and this coming from denominator. I will explain this in a separate video. Just form the values and calculate the value of the test statistic from here. You don't need to do anything with this. This is just for information, and this will give you some value, this portion. Now the fifth step is determine the value of f. So you will have some value for m. Suppose that is 3, so this will have 2 degree of freedom. And suppose m is again 3, so that is 3, and n is 3. So this n minus 1 will give you 2 and 2 3 6. So you will have 2 and 6 degree of freedom. You know, F distribution has 2 degree of freedom. I will explain how you will see the table. I will have a separate video on this. And this is significance level. So F with this degree of freedom and this degree of freedom and 0.05, you need to look at the table, this value. And the next step, compare the calculated value of the test statistic with the value you determine from the table and decide as below. So you have this value from for test statistic from the data, and you have this value from the table. You need to compare these two values, this TS value with this F value, and reject the null hypothesis. The decision should look like this. Reject the null hypothesis. FTS is greater than or equal to F. You know this one. FTS is greater than or equal to this value. Reject the null hypothesis. Otherwise, accept the null hypothesis. In conclusion, the last step, conclude according to the condition given in step 6. So whatever the condition is, if this is satisfied, then we will say, okay, we have enough information to reject the null hypothesis. And if the TS is less than this value, then we will say, okay, we have no sufficient information to reject the null hypothesis. So this is all about the theory of, or you can say general procedure of hypothesis testing under the one factor analysis of variance. We will have an example with the data, so then perhaps you will understand very clearly what is meant by this and how we can do this. I think this is enough for today, and thank you very much. See you in the next video. Ciao.